This is section 2.1 of Honors Algebra 2, solving inequalities in one variable. So this section and the next several sections are all about inequalities and solving them. So it's important that we take a moment at the beginning of it to understand what an inequality is and what it does. So what does it mean to say that x is greater than negative 2? That sentence, that mathematical sentence, what is it saying? Well, it's saying that we'll accept all real numbers for x that are greater than negative 2, that are bigger than negative 2. We'll take anything bigger than negative 2. Will we take negative 2? No, because it's not bigger than itself. And we're strictly greater than negative 2 here. So we'll take anything bigger than negative 2. Does that mean the first number we'll take is negative 1? No! There are an infinite number of numbers between negative 2 and negative 1, right? Negative 1.5. Negative 1.98753. There's a whole bunch of numbers in there, and we can't forget about those. So how do we represent all of these numbers? Well, we can represent it with this really sentence, x is greater than negative 2, with those symbols there, or we can represent it with a graph on a number line. So that's 0, and that's 1, and that's 2, and that's 3, and that's 4, and that's negative 1, and that's negative 2, and that's negative 3, and that's negative 4. How do I graph this whole range of numbers? Well, I start at negative 2. To indicate that I'm not including negative 2, I just put an open circle at negative 2. If I was actually including negative 2, if I had greater than or equal to, I would put a closed circle, a dot, at negative 2. And greater than negative 2 is everything to the right of negative 2, so I shade that in, draw an arrow on the end because it never ends. It keeps going up as high as I want it to go. It has no limit. So that's the basics of what an inequality means. You know that already. Solving inequalities, we really solve them like equations. And we have properties to solve equations with, and we have properties to solve inequalities with. And we call them properties of order, properties that tell us about the order of numbers, that some numbers are bigger than others, some numbers are smaller than others. So let's let A, B, and C be any real numbers. And these are not variables, they're fixed real numbers. So we know certain things about them. We know that we can compare any two numbers. For any two numbers, exactly one of these three scenarios must be true. Either A is less than B, A equals B, or A is greater than B. One of those has to be true. There's not a fourth option, and we can't have more than one of those be true. So exactly one of those has to be true. That's called the comparison property. We also have the transitive property, which, as the transitive property always does, forms a chain. That if A is less than B and B is less than C, then it must be true that A is less than C. We have the addition property that says we can add the same number to both sides of an inequality. If A is less than B, then A plus C must be less than B plus C. I can add C to both sides of the inequality and it will not change it. Now subtraction is really addition in disguise. So I can subtract the same number from both sides, again using the addition property, because subtraction is really addition of a negative number. So subtraction is allowed through the addition property. I also have the multiplication property that says if A is less than B and C is some positive number, some number greater than 0, then A times C must be less than B times C. I can multiply both sides by a positive number and it will not change the inequality. But if A is less than B and C is some negative number, some number less than 0, then A times C is greater than B times C. If I multiply both sides by a negative number, then it actually switches the sign. And realize that division is another form of multiplication. It's multiplication in disguise. Division is multiplication by the reciprocal. So division is allowed via the multiplication property. So again, if A is less than B, then I multiply by a negative number, I must switch the sign, and it becomes greater than. So anytime I multiply or divide an inequality by a negative number, I have to switch the sign. That's the one difference in solving inequalities versus solving equations. Because if I flip an equal sign, nothing happens. It's still an equal sign. So now let's practice solving a bunch of inequalities. Our directions: solve the inequality and graph its solution set. Because there's not just one number that's a solution anymore. There's a whole range of numbers. Just like our solution to our original inequality, x is greater than negative 2, there wasn't just one number that's greater than negative 2. There's an infinite number of numbers. So we represent that as a solution set, and we can graph it on a number line. So number 1, 5x plus 17 is less than 2. We want to get x by itself, as we want to do any time we're solving something for x. So we move the 17 to the other side by subtracting 17 from both sides of the inequality. The addition property says that I can do that. So I get 5x is less than negative 15. I divide both sides by 5, and x is less than negative 3. I divided by a positive number, so I did not have to switch the sign. I can write my solution just like that. X is less than negative 3. Or I can write it in what's called set notation, which uses these braces. And it says, I'll take all x's, the set of all x's, such that vertical line means such that, all x's such that x is less than negative 3. And I close the braces. That's called set notation, and you'll begin to see that a lot in this class and in future math classes to represent answers to problems. So that's two ways we can write our answer. We can also write it as a graph. And we graph it putting a 0, negative 1, negative 2, negative 3, negative 4. We put an open circle at negative 3 because we cannot include negative 3. We don't have less than or equal to, and less than is to the left. So we shade it, put an arrow on the end to indicate that is the set of solutions we want, anything less than negative 3. Okay, number 2, 5 times 3 minus y is less than or equal to 7 minus y. Distribute the 5, 15 minus 5y is less than or equal to 7 minus y. I bring the y's to one side, to the left side, so 15 minus 4y is less than or equal to 7. Subtract 15 from both sides, and negative 4y is less than or equal to negative 8. Divide both sides by negative 4, and y is greater than or equal to 2. Well, 4 was a negative number, I had to switch the sign. So y is greater than or equal to 2. In set notation, that looks like the set of all y such that y is greater than or equal to 2. And I can also graph it on a number line. 0, 1, 2, 3. I put a dot at 2, a closed circle, because this time I am including 2 in my solution set. And I shade to the right for greater than and put an arrow on the end. Number 3. 4x is greater than 2 times 3 plus 2x. So to solve it, I distribute the 2. 4x is greater than 6 plus 4x. I bring the x's to one side by subtracting 4x to the left side, and I get 0 is greater than 6. 0 is greater than 6. It doesn't seem right. It's not true, is it? What do I do? What do I do? What do I do? Well, that's not a true statement, right? That's a false statement. So there must not be anything that satisfies that inequality. So I write no solution. No matter what number I plug in for x, it will not make that inequality work. It's a fundamentally flawed inequality because 0 is not greater than 6, or my kindergarten teacher lied to me. I probably learned that earlier in the kindergarten, so I've been lied to my whole life if that is correct. So we write no solution. If all of the variables are eliminated and we get something that's not true, we write no solution because there's nothing that's going to make that work. Now we look at number 4. 2t is less than negative 1/2 times negative 6 minus 4t. I distribute the negative 1/2, so 2t is less than 3. And negative 1/2 times negative 4t is positive 2t. I bring the 2t's to one side, and I get 0 is less than 3. But wait, that does work, right? 0 is less than 3? I think so. But what do I write? What do I do? What do I do? Well, that is a true statement. So all the variables were eliminated, and I got something that was true. That means no matter what I plug in for t, I can plug in anything as big or as small or as positive or negative as I want, and it will work, no matter what it is. So my solution set is all real numbers. Any real number I pick, plug it in for t, the left side will be less than the right side, and that inequality will work. So we have special notation to represent these two special possibilities as for answers. No solution is represented by the 0 with a diagonal line through it. It's called the null set. That means there are no solutions. There's nothing in my solution set. It's the empty set. There is nothing in the set of solutions. And all real numbers is represented by this R with a double vertical line. That just means the whole set of real numbers. Now, can I graph all real numbers? Sure. It's going to be an entire full real number line. So I'm going to put 0 on there to indicate that it's a number line and to orient the number line, and I'm going to shade the whole thing from left to right. Can I graph no solution? Sure. Be an empty number line and be boring. We're not going to bother with that. How about a word problem? Those are always fun. A bus is being chartered for the sophomore class trip, the Road to Freedom. The basic fee is $95 per person. If more than 20 people go, everyone's fare is reduced by $3 per person over this number. That means if 21 people go, the price per person goes down $3 for everybody. If 22 people go, the price per person goes down $6 for everybody, and so on. So at least how many people must go to make the fare less than $75 per person? At least how many people must go to make the fare less than $75 per person? How many people do I have to add over 20 in order to get that price down from 95 to 75? So anytime you see the words at least, know that that means you're going to be using an inequality. Because there's not just one number I want. I want the minimum number, and I want to know the whole range that I can take. It's going to be defined by that minimum number, but I can take anything bigger than that. So we know the 4 steps to solving a problem, a word problem. Let's start with step number 1. And let's define our variable. Well, we are interested in the number of people, so we're going to let x be the number of people on the trip. The number, let x equal the number of passengers, the number of total people on the trip. Okay, step 2 is I organize my information, the information that's presented in the problem. So if x is the number of passengers on the trip, then how do I write the number of people that I have over 20? Well, that's going to be the total number of people I have, which is x minus 20. That's the excess number of people, the number of people over 20. And I want that number to be pretty high so that I get my price down. So x minus 20 is the number of passengers over 20. Well, if there are x minus 20 number of passengers over 20, if I multiply that by 3, that's how much I get to take off on the price per person. If there's 22 people, I get to take off 2 times 3, which is 6. So 3 times x minus 20 is how much I get to take off. But I'm taking that off of 95. So 95 minus 3 times x minus 20. That is how much money I'm paying per person if I have more than 20 people. And I want that to be less than what? Less than 75. So I want the total, I want the price per person, which would be 95 if I have 20 people or less. I want that to go down, and it's going to go down by $3 per person that's over 20. So I've got 95 minus 3 times x minus 20. X minus 20 is the number of people over 20. Multiply that by 3, that's how much I get to take off. And I subtract that from 95, that's what I'm starting with. I want that to be less than 75. So now I have an inequality. Step number 3, let's solve the inequality. 95 minus 3 times x minus 20 is less than 75. So 95 minus 3x plus 60 is less than 75. 95 plus 60 is 155. So 155 minus 3x is less than 75. I subtract 155 from both sides, and negative 3x is less than negative 80. Divide both sides by negative 3. And I'm dividing by a negative number. So what does that mean? I have to flip the sign. So x is greater than negative 80 over negative 3, which is 26 2/3. So x must be greater than 26 2/3. If that is the case, I'm paying less than $75 per person. So step number 4, let's make sure we answer the question. What was the question that we were asked? At least how many people must go to make the fare less than $75 per person? Well, at least 26 2/3 people, right? What's a 2/3 of a person? I don't know. So we want to say that at least 27 people must go. And if so, we'll be paying less than $75 per person. Okay, here are your immediate practice problems. 2 problems. Solve each inequality and graph its solution set. For each one, you should write the problem, solve the inequality, and graph the solution on a number line. And that is the end of section 2.1.